red, green. Okay, hi, I am Yogita. I will be taking your physics class. If this is not your first class, right? Let it be this. Can I know your name and school?
Aratrika Malik and
Avantika.
Aratrika.
Aratrika Malik from which school?
Avla.
Parts. My school name is Goldfish Vashi. Okay, you're from Goldfish and Parts. Okay, both of you. Let's begin with the chapter. Your schools have started.
Yes.
Yours.
My first chapter. My school started the first chapter.
Okay. So we will be doing today this chapter called measurements. And I think yes.
The first chapter is measurement and experimentation, but in my book it is current limits.
Okay. Can you?
We have started measurement.
Okay. Which book are you referring to? Like this? Selena, right? Selena's first chapter. Okay, you mean in your school they haven't started with this chapter, they started with current electricity. In your school they started with measurements. Okay, Parth will do one thing. Today we'll start with measurement chapter because any which way this is basic which you should know before moving to any chapter, and then we can go and speak. Like we can discuss which chapter and how it should we go about. Okay, is that okay? So we'll start with measurement. Before doing measurements, yes, yeah. Before doing measurement, you tell me you know what measurements mean, right? You must have measured something in you are in 9th grade, so before that you must have measured many things. Can you give me one example of what you have measured? Rice. And what about you?
We measured weight of anything.
Okay.
Measured our weight.
Okay, your weight. Okay. So for that, if I say give me some rice, so can you give me some rice? So what will you ask me?
1 kilo rice or
So so we need to be specific, right? And for that we use this thing called measurement, because when we say measurement we have to be accurate. What exactly are we talking about? How much do we want? Okay. In terms of numerical also, like we need to tell it in terms of numbers, numerical value, plus we have something next to it. You will tell me that. So like she said, we measure weight, we measure length of this table. You must have done this in your classroom also, board measurement or something for your dress measurement, something like that. So when you give numerical value to it, you say that in physics language we call that magnitude. What do we call that? Magnitude. So let's say, what is your weight? Can you give me 49.5? Okay. But so this was my next question. Can I just say 49.5? If I say give me some, I'll say 2. Is that enough? No, we need to add something next to it, which is even more important. What is that? It is units. You specify in what, like 42 grams, 49 grams, or 49 kgs, or 49 quintal. You need to be very specific what we are talking about, right? So this measurements has magnitude, which is a number like 40, 50, or whatever it is, and it has numbers. And what is measurement? What is measurement? We actually know something already. I know how much 1 kilo is. Okay, and then I compare that with something else. Like if I am comparing it with your weight, then I will come to know, okay, how many these 1 kilos will make this weight. Okay, and I already know this much measurement is 1 meter. Then I go like this is 1 meter, then this one or 2 meter, and like this. What am I doing? I am comparing with the known thing with the unknown thing. That is measurement part. Since this is quite basic, we will not delve deeper into that. We'll quickly move to the important part, which is units, which she said it's not just 49, it's 49 kg. So there are two kind of units. One is like, yes,
and derived.
Instead of saying units, I'll say quantities. There are two kinds of quantities. Physical quantities, fundamental quantity and Derived quantity. Fundamental and derived. As the word means, what is deriving? It is derived from something else. Now, what does that mean? Fundamental is, it is original. You don't need something else to explain that. Okay? How do I explain you this? If I say, what is the length of this table? You will say it is 10 meters, 3 meters. Or by taking an estimation, how much do you think it must be in terms of meters? 4 meters, somewhere around like this. This is 1, 2, we'll say 2 meters. Okay. So, we say 2 meters. Let's say we say 2 meters. What is this? We talk about which fundamental, not fundamental, let's say which physical quantity are we talking about? We are talking about length. Okay. We have studied, this is which shape? What shape is it? Rectangle. Okay. This is, you already told me 2 meter. This would be somewhere around what? 0.25 meter, 1/4 of meter, this 0.25 meter. Now I want you to tell me what is this surface area that we are using. So basically I want area of this rectangle. Do you remember rectangle's formula? Area of rectangle? Length into breadth. Yeah, it's length into breadth. So area is equal to length into breadth. Okay. What is length? How much is the length? 2 meters. 2 meters. How much is the breadth? 1/4 of the meter, 0.25. I'll make it easier for me. I'll write 1/4 of the meter. How much is the answer? 0.5 meter square. Meter square. That's the unit of that's the unit of area. Here itself you see that this is nothing but what 2 meter is nothing but a physical quantity called length. This is also half meter physical quantity of length. Let's say distance. They are both physical quantity. Like I use ruler for this. I use ruler for this. They are both same quantity. I have just given name difference, but they are actually same quantity. But this area is actually derived from this quantity. Is it something on its own? I use length for that. What is area of square? Side into side. I multiplied side twice, right? So, area is something which requires another quantity for its explanation. It is not something on its own. So, that kind of quantity is called derived quantity because it is derived from some other fundamental unit. Which fundamental unit do we use for area? We use length. It is actually length into some length. We call this name as breadth. Otherwise, in terms of other thing, we call it width also. But then, which quantity is it? It is length. Okay. Can you give me another example of derived quantity? Pressure. Pressure. What's the formula for pressure?
Force by area.
Yeah, it's force upon area. It has nothing to do. Okay, that's fine. It has nothing. This will ring. So, in case I do not hear it, please tell me 10 minutes before the session is about to get over. So whenever so like she said, pressure. What is the formula? It is pressure is not it is not a quantity on its own. It is derived from some formula. It is force upon area. Okay. So this is also a derived quantity. Okay. In case derived quantity, you do not remember formulas. You at least tell me some fundamental quantities which are on its original. They do not need any other formula for its explanation. Like I already gave you length. We simply don't meter, kilometer, centimeter. It's on its own. We don't need a formula for that.
Mass.
Mass is an. We just talk in terms of okay, what is your mass? You do not know what is the formula for mass. Do you think that? So that is another physical quantity. Can you think of something more?
Distance.
That comes in that. What is the unit of distance? Kilometer, meter also, right? Like centimeter. They are all distance. If an ant is moving, you won't say it is moving 4 or 2 meter or that. You use centimeter for that. That is some other units, but the quantity that we are talking about is length. We call it length, we sometimes call it distance. That's same. Mass is done. I'll give you an example.
Time.
We'll come to that. Time. For time, what's the formula for time? No. How much time it is? In seconds also, you can say an hour also, so you can say something. You don't need a formula for that. So time, these are the 3 main important things by the way. Why we'll come to that. Does anything else come to your mind? Like, you do this. 10 Temperature. What's the unit for temperature?
Celsius.
Celsius is there. Some other units, do you remember?
Kelvin.
Kelvin is there. Okay, Fahrenheit is there. Good. Any other fundamental quantity that is coming to your mind? Like it's done in your class, so I was looking forward to you. At least it's okay if it doesn't. No? Okay. We'll move to you. You said force, right? Force also has some formula, which you are not aware because you have not studied. Do you remember force formula? There is a formula for force. That is actually mass into something called acceleration. You don't know it, that is why you thought it is a fundamental quantity. What is force? It is derived quantity. Can you think of some other example for derived quantity? Area?
Density.
Yes, density is what? Mass upon volume. Very good. That is derived. Very good. Speed, path, speed's formula. If you can, like in mathematics class, you must have done it.
It's over time.
Yes, it's distance upon time. Okay, but this question is for you. Something called volume, right? Is that derived or fundamental? The first question that should come to your mind, does volume have a formula? Does volume have any formula? Is it?
Yes.
Like volume of Q, I know. Volume of cuboid, I know formula. If I know a formula, it's a derived. Like what is volume of Q? What did you say? Side into side. Remember? That is why for volume we say meter cube or centimeter cube. Like for area we say meter square. For volumes unit we say meter cube, centimeter cube. But for easier way we sometimes use liter, but that is just a shorter volume. But otherwise that is the proper unit. So volume is again another example of derived quantity. Is this clear? Which is what? There are few more fundamental quantities. We'll discuss that later because that's just an introduction. We don't study about that. So maybe that is why you don't remember the names like candela, intensity, or flash.
Actually, we didn't in class. It was a cell study. Like a study.
Okay. That was. Okay, maybe that is why their school started directly with current electricity, right? So maybe after finishing this, we can move to current electricity if that's okay with you, right? Is current electricity done in your class or
Chance.
do you understand?
Yes. The reason was that it was the thermophysics which we did the topic.
Whose is it favorite topic?
The common teachers.
Okay, so that is the reason she or he chose current electricity. She or he.
I teaches for 9, 10, and 11 at the same time.
Same topic you mean?
For 9, 10, for 10, he adds more and more.
So for him it is easier also because the same topic is going across the grades. But then he knows what to teach you. Then next class and next class so that you all are at like, it's good for him also and good for you also. He doesn't mess up, otherwise something can happen.
No, I need the same class. For example,
How? The same class.
For example, we are taking off the YOGITA data. Then he teaches for the 9th. And in 9th it is some a short definition. Then in 10th it is explains further. Then 11th.
But you mean not in the same classroom, right?
No, I mean the same time. At the same time he explains all.
Is that a good thing or bad? Because I'm not getting you.
First, we start from step by step. In 9th we teach it. Then the teachers, some teachers tell us that we learn it further. But this our sir, he teaches us at the same time after 10th, 11th, 12th.
Oh my god.
He teaches further and further and further.
Oh my god. Okay, I got it. Okay, so that like you know more than what you should know, you know. That's in a way sad, but for the ones who really enjoys learning that topic, it's good also. I don't know about you, but let's not discuss that. I don't want to bother you.
Means we don't even understand what he said.
I understood your frustration at the time. It's okay, it happens. He just loves to discuss maybe, his passion for physics is You should tell it sometimes to yourself. Then it would be easier. Let's not discuss that. Let's finish this so that we can quickly move to calculus, so that you understand that better for the remaining classes of this, and you can question it also. So where were we? Fundamental and derived quantity is done. Now we are moving to something called these things that you would see it in your physics books all the time. So these things should be very clear to you. Not this one too much, this one of course. So I'll give you one hint, then you will tell me what's the answer. So this is a unit for length. This one again for mass, and this one for time. So you of course know what does S stand for. Seconds. So it was very easy. This is something with respect to mass. No, mass there is no pressure. I'll give you more hint. This was used in British influenced regions in past. Even now they use these terms, and this was used in France, like French, French colonies and those influences during past era. But it's very easy. G is also very easy in terms of mass. You should know what is G. That is gram. Of course, then what does C means for length? Centimeter. So this one is done. Okay, test is passed. What about F then? F in terms of length and P in terms of mass. I have already given you the in British. If you have not them, they always use ounce and pound. Okay, this is pound, unit of mass for British, and this is foot. Remember, they say even dimensions of room in India nowadays they use meter. Of course, in Britain, how much is it? 10 feet, 20 feet, something like that. 20 feet by 10 feet. Have you heard this? 10 by 10 cover, 10 feet by 10 feet. So, this is foot, pound, second. Centimeter, gram, second. So what were these? You know, in previous, like right in 1880s, yeah, those time, all the countries were using their own different unit system. What happened later when they were trading with each other? We are dealing in terms of kgs, and British and those influenced region were dealing in terms of pounds. Okay. When while trading, understanding each other and all those trade related things, it became quite tedious, and they came together, they sat together, all of them, like almost all the whole world countries, and they started and they decided, okay, all of the countries of this world will have one uniform measurement systems. So they will have a same international system of units. Okay, they will stick to those units when they are dealing at the international standards level, and they name that as SI unit. What did they name it as? SI unit. SI like system of international units. And for this, they chose for length. Of course, you know what they would have chosen: centimeter, foot, or something else. Meter. They chose what? Meter. Okay. For gram and pound, they chose something else. What would that be? They chose kg. And since there was no clashes over here, they kept it same. Sometimes we call this SI units MKs, but just for our reference. Okay. But otherwise, in future, if somebody asks you what is SI unit of length, you should always answer what? Meter. What is SI unit of mass? Kilogram. And of course, what is SI unit of time? Second. And if I ask you what is SI unit of area?
Meter square.
Yeah, meter square, because what was the formula? Length into breadth. Will I take my length in terms of foot or centimeter? No, what was SI unit? Meter. So I will take meter into meter. Then I will become meter square. What is SI unit for speed? What was meter? What speed? What was the formula? Distance upon time. Meter square.
Meter seconds.
Randomly anything. What is SI unit of distance?
Meter per seconds.
It's meter na length, distance, all those are same only na. We chose the SI unit. What did we choose? Meter, right? So it is use meter? Time, of course. How did you make it hour when even they were not having clashes? What is the second unit of speed? Meter per second. And henceforth, like whatever you study in your current electricity also or anywhere, they will always talk about SI unit, SI unit. So you need to know what is SI unit, okay? And in case there are some references with respect to length, mass and time, then you know what to choose, okay? So for them, meter is very easy. So for length, distance or anything, we will use meter. For not weight, for mass, we will use kg. And for time, we will use second. Is this clear?
Yes.
I can talk because your textbook has quite in depth of the whole story also with respect to 1 kilogram, 1 centimeter and everything. You can also go through that. I will discuss that in brief. So they talk about international system of, not this book, I am talking about Selena. You use all of you are referring to Selena, right? In almost all ICSE schools they refer to Selena. So what I was saying, yes. So you see this kgs, you see these meters, but there are definitions. How did they, like I said, we have something known and then we compare and measure. But then for measuring that known, how did they come with that measurement? So it was very, very much accurately done by that laboratory in Paris. Yeah, in Paris. In France, in Paris. International Standards of Weights and Measurement. You can see that if you make you want to see the reference point. This is SI unit, this is this okay, that is coming ahead. It's okay, I'm not able to find it. If you read it in Gadget, it's actually there, but let me quickly discuss why to waste time. It's any which way story. So what they use
What is the full form SI unit?
International System of Units, or they say System of International Units. That's why in future nobody is going to ask for full form of SI, but they will always ask SI of force, SI of area, SI of volume. What is SI? SI unit of volume. So you need to understand what were the fundamental quantities of SI? Meter, kg, second. That should be very clear. Okay. And yes. The story. So what happened? So like I said, so how much is 1 meter? We had already predefined it somewhere. So in that laboratory, International Standards of Weight and Measurements of Paris, they had defined. What they had was, actually they had this cylindrical weight platinum iridium small cylinder which was weighing 1 kg. Okay, and in 2019 it was in news that they had removed, just imagine the 1 kg reference point which the whole world uses is actually sitting where in that laboratory in that tiny glass frame, and it is sitting there from like more than even centuries over there. It's sitting there. What happened over a period of time? Scientists and everybody realized that some weight of that had actually reduced because so many years somewhere it had disappeared. How much weight did disappear? It's somewhere around weight of your eyelash. Okay, people like me and you say, oh, that's okay. Like only eyelash difference, it's fine. There's no need to remove that. But that eyelash difference can make a lot of difference. Just imagine that thing is a reference point for gold's measurement, for so many other things measurement, for so precious measurement. That even 1 gram of gold is so महंगा. Over a period of time, if this thing does these kind of errors, आज glass का वजन कम है, tomorrow more and more deterioration can come. So what they did in 2019, it was quite in news. They removed that and then they redefined the new kg with something called Planck's constant. So no longer are we using the previous cylindrical thing. Same happened for kilometer also. For meter thing, they were using something else like these slabs and cylindrical stuffs made of platinum iridium and further. They were very fine metals, less prone to corrosion. They removed, replaced that with a new system. This time for measurement, the standard meter thing is predefined with the help of speed of light. Do you know what is speed of light? No? Like years is speed of light for in years. In 1 year, how much light will? In 1 year, how much light will travel? I'm just asking you in second, how much light will travel? Because speed of light in meter per second. It's this much, like 3 into 10 to the power 8. That's the speed of light. Okay. So they use this reference point. Okay. If the speed of light is this much, then in like this is meter in 1 second. 1 second. So 1 upon 3 of this part, like this upon this part is like 1 meter part. This much part is 1 meter. In like definition method, they said. Why they did this thing is, what did I tell you? So wait, I'll explain this to you again because it's there in the textbook. What is speed of light? Speed is distance traveled in per second, right? We say meter per second, right? What did I say? Speed of light is 3 into 10 to the power 8 meters in 1 second. What is the definition? They wanted to define how much is 1 meter. This is the 3 into 10 to the power 8, like 3 0 0 0 0 0 0 8 times zeros. I just want what is 1 meter. So 1 meter is equal to, if I want, what will I do? You know how to make it 1 meter, right? I do 1 upon 3 into 10 to the power 8 second, right? Right? So in your textbook, you will see that 1 meter is defined as distance traveled by light in 1 upon 29966 something like this seconds, because 3 into 10 to the power 8 is somewhat closer to 1 upon 299. Just see that. So you should not get confused what exactly they're talking about. Do you see that? No? Okay. Here.
Yes, ma'am.
Yeah. You see, this is, so they have given 299 whatever, that is approximately 3 into 10 to the power 8. So this is how they define 1 meter. Are you seeing this? Did you get this? How they define 1 meter? Just imagine. But they need this complicated method. Why? Because never in your lifetime, be it like anywhere in space or anywhere else, will speed of light change? No.
This is in the air or vacuum?
This is in like in air or vacuum. We say speed of light is this much only. We say it in air or this, but in some other mediums like in metal or some glass, the speed is different. But we keep it same, like somewhere around closer to this. This is approximate. The exact one is like 1 upon 29966. You know, you have written. They have given it there very clearly. And just count how many digits would be there, somewhere around 8. So 299 becomes 300 only, closer to 3. So that is why 3 into 10. Anyway, it was in future also. If somebody asks, nobody will ask you. You have to know this as of now. Like henceforth, speed of light. You need to know what is speed of light in physics and in air or vacuum. You will say it is how much? 3 into 10 to the power 8 units what? Meter per second. Okay, is this clear? The definition is clear. I wanted to discuss that so that you do not get confused. So let's quickly discuss the other units now they use. Okay, meter is done. Then we have so many different units. Basically, the prefixes that we use for our measurements thing. So you see your textbook, I'm writing it quickly. You can even read it out so that I can be very quick. You see deca, hecto, kilo. Do you see something like this?
Yes.
What is after kilo?
Mega.
Mega, giga,
Tera.
tera,
Peta.
peta,
Exa.
exa, EZY, easy, zota, and X, EZ and Y. Exa, zota, and iota. I am writing this. You don't have to learn that. Your textbook won't ask you to learn that. But I am writing this to give you some logic behind this so that in your higher grades it will be helpful to you. Please pay attention to this. You see deca. You see this. You just see this. You very well know that 1 kilogram is equal to how many grams? 1000 grams. Can I write 10 to the power 3 then for 1000? So this kilowatt actually represents what? 10 to the power 3. This we know. So that's great. This we know. Kilowatt actually means 10 to the power 3. Because if I had written 1 kilometer, then also it is 10 to the power 3 millimeter. Right? Kilowatt, because I remove this and go 10 to the power 3 meter. So the kilowatt is 10 to the power 3 meter. The kilowatt is 10 to the power 3. So these are the words that we use in physics and higher grades. Something will come in terms of giga, peta, some or more. That is why we do this. So deca is 10 to the power 1, hecto will be there 10 to the power 2 and kilo is 10 to the power 3. After 3 everything becomes double of what was the previous one. What is double of this? 6. 6 plus 3, you add 3. So 9 plus this, 12 plus 3, then 21, and then 24. Is this clear? Of course, you see this, you will get a migraine because there is quite a lot to remember. What you need to remember is at least I highlight this. You should not forget henceforth. This, of course, you know, right? You should know mega and giga also. I missed something. Did I? No, right. Deca, hecto, kilo. No, I did not miss. Okay. So, this is important. Now, this for higher, you see this is 10 to the power 3. So, these are for higher weights or higher meters. If an ant is moving, will you use meter, kilometer to measure its distance? You will use smaller units. We have something like that also. For deca becomes what? Deci, centi, milli, what is micro, nano, and atto, zotto, and yotto. Just forgive me for my spellings. I'll tell you what is to be remembered now. And now, since you know this, and these are the smaller units, what will happen? We know what was happening with centimeter. 1 centimeter. The word centi, what will that do in terms of meter? How much is it? 1 by 100. Right? It's the 100th bhag of meter. Meters this used. Cut them into 100 pieces and take one piece, that will be equal to centimeter, right? So 1 upon 100, that is nothing but in mathematics we write 10 to the power minus 2. Is that correct? You know about this? So let's start with this minus 2. So we of course know what is decimeter, 10 to the power minus 1. This will be how much? Milli, of course we know it's 10 to the power minus 3. What is micro then? 10 to the power minus 6. Nano is 10 to the power minus 9. Pico is 10 to the power minus 12. Femto is 10 to the power minus 15. Octo is 10 to the power minus 18. Sorry. 10 to the power minus 21. Minus 24. Again, don't get migraines because of this. We will stick to what needs to be remembered. I presume you know this. It's good if you know decimeter also. There's no harm. It's good. But majorly, you need to know micro, nano. This is very important. Why? Because in physics, if even you see series or anything, they say nanoseconds, nanotechnology. So everything is in terms of nanometers, those small units, so nano is important. Micro is also important. So micro, nano is important. The other one that you need to remember is femto. trust me, if you remember even these somewhere, you will remember these things even if you don't want to remember. How will you remember this? There's no need, I'm not forcing you to remember. If you remember, it's good. If you are great remember, it's fine. But at least these things you should remember. What for this? How do you remember? Okay, look here, I'm just helping you out. It's like decahectones, okay, it's difficult. Kilo, we already know. We can start from here. Mega, giga, tera, pita, easy. E, Z, Y is easy. Right? So we know at least how is the, it comes E first, then Z, and then Y. And here everything, A, say N, jo, the R sound that is coming, those are for higher units. And the OO sound that are coming, that is for low, the smaller units. So even in examination, this is bigger, that way you should at least have that much in memory that this is which one, the smaller one. But no way, you have to remember micro, nano, and femto. Femto's other name is Fermi. For distance, it is Fermi. Okay. So if say Fermi, that is how much? 10 to the power minus 15. Okay. You will get to know in your textbook, but that's fine. If you remember femto, then there's no harm. Any which ways remember Fermi. Is that okay? Shall I just erase this? Take a look. I'll quickly ask you. Let me see how do the memory check. Even after 5 seconds, do you remember these? I can ask anything from this. I can give you hints also. You know, nano is the word 9. Like 9 and nano is somewhat similar, so it should not go wrong over here. And you know there is minus sign because nanotechnology, nano is like for smaller ones. And micro also has minus sign because we cover microorganisms. Femto 5 sounds, so you can remember it like that. Shall I erase it? That? Okay. It is still visible, I guess. Okay, I'll ask after some time. Or maybe quickly I'll ask. Femto 10 to the power minus 15. Nano 10 to the power minus 9. For 10 to the power minus 6, what is that word? Micro. Giga 10 to the power 3. Giga 10 to the power 9. Yeah, 10 to the power 9. Then what is, oh, we have 10 minutes more. Okay. And mega 10 to the power 3. 10 to the power 6. Why are you stuck at 10? 10 to the power 3 will be what you tell me? Kilo, yes. Started that. Okay, I will go ahead because these are more important. Light, I think you spoke about light year, right? So we will study about these 3 things: light year, astronomical unit, and the last one is parsec. See, the whole purpose of doing this is so that when you read the chapter, it should not be a headache because it is quite in depth. You should know how much is important. Okay, that is why your teacher is giving this for self-study. But the language is quite difficult and definitive. So that is why I'm explaining this. Keep your books open. We'll start with astronomical unit. This is the most easiest thing. Now, you know, sometimes the 10 to the power 15, 10 to the power 24 is also not enough to measure a distance. For example, like how far are we from sun, right? Do you think those kilometers or meters or 10 to the power will be enough to measure our distance from that? No. And even if you want to measure something in terms of some other planet or some other star, okay, that's not enough. So we have these astronomical units that we use. First one, not the astronomy, like the 3 different units for astronomy measurements. First one is the easiest one, astronomical unit. It starts with the basic thing. We start with Earth and Sun, okay, and we define it as 1 astronomical unit. How we define 1 meter इतना होता है, तो हमने define कर दिया कि Earth and Sun, like she is Sun, I am Earth. Oh, distance between us is how much? 1 astronomical unit, okay. And let's say your sun, there is another similar star at the same distance from me, and that is path. So how far is path from me? Again 1 AU. But let's say path was behind you and in exact same distance that we are from you. Then how far is path from me?
2 AU.
2 AU. Understood? So what is 1 AU? That is clear. That is distance between what and what? Earth and sun. Clear? That's AU. And of course you say 1 astronomical unit. This is clear? Shall we move to next? Light year. We know light. We studied, not studied, happily studied. We just discussed what is speed of light?
3 into 10 to the power 8.
8 meter. But does it take 1 year to travel that much?
No. A second.
So in 1 second, light travels itna. Like 3 into 10 to the power 8. Let's say this is 3 into 10 to the power 8. In 1 second only. But I want to see that if light goes from me, okay, and after a year where it reaches. Have you thought about, I don't know if you have heard this thing. They say the light that is reaching us is actually past. It's very old. Why? Because it doesn't reach in instant to us. It takes years to reach from there to here. Okay? By the time that light has emitted from sun and reached us, it has been from sun to earth. We know how much time does it take. You know 1 astronomical unit for measurement. We'll do that Duri, how much that is divided by 3 into 10 to the power 8. It takes somewhere around some seconds. We can do measurement now. We'll discuss that. But it doesn't come in 1 second. By the way, we have a 3 into 10 to the power 8 ki Duri. Okay. If you are that, we'll see that. If in case we have some time left, we'll check that calculation. Otherwise, that is an homework. That is a homework. You have the textbook, right? What are we checking? We want distance of Earth and Sun, and you tell me how much time light will take. You the speed of light already. We can discuss that in next class. 8 minutes. Let's see. Don't remember as but it's a last. Okay, but we can do that calculation and verify. I would have certainly done it today if this was the last class I have to 10th class. Would have been interesting. There was not light here, but we can do this calculation. So light, but how much light travels in 1 year? Okay. So of course in 1 second it is reaching 3 into 10 to the power 8. In 1 year it will be certainly far more than this much, right? So for that at least I need to convert 1 year into seconds, right? How much 1 year in what? Seconds. Do you know how much 1 year is equal to? Let's do the calculation. 1 year is how many months?
12 months.
Okay. Why did I say the months? How many days? That is very easy. 365 days. So let's convert that into days. And we know that 1 day is equal to how many hours? 24. So 365 days into 24 we'll convert that into hours now. Did you understand what I'm doing? Let's convert this hour into seconds. Like 1 hour is how many seconds?
3600.
3600, like 60 into 60. Or we can do step by step. 1 hour is equal to how many minutes? 60. So multiplied by 60 minutes. But 1 minute is equal to how many seconds? 60. So 60 seconds. Finally, I got my answer of year in seconds. Right? And I already know in 1 second how much my light travels? 3 into 10 to the power 8. In 1 second. So in these many seconds, how much will it travel? Multiply and get the answer. If you can multiply, I think your textbook has already given it is somewhere around. Just check and tell me. 946 into 10 to the power 15 meter. 9.46. Give me the number.
9.46 into 10 to the power 12 kilometer.
10 to the power kilometer in terms of meter. Let's stick to meters only. 10 to the power 50. 50 नहीं होगा ना? If it is 10 to the power 12 kilometer, and if I add kilo का 10 to the power 3 multiply the 12 plus this will become 15 only ना? Yes, it is 15 meters only. Okay? Or you can say 10 to the power 12 kilometer. So this much is 1 light year. So if somebody asks you what is 1 light year, 1 light year is equal to 9 is this into 10 to the power 15. Is this clear? We shall not delve this deeper. It's not that much. All you need to understand what is 1 light year. In case somebody asks you what is 1 light minute, so convert minute in terms of seconds, okay, and multiply it with the speed of light. If say 1 light, what day? Speed of light into 365 days. But they don't use days and minutes and all. They always use light years only. Like the closest star to our Earth, to the sun basically. Other than sun, the closest star, which is what Proxima Centauri. It is somewhere around, I think, 4 light years away from us. We'll use this is, I don't know why have they put this, because you don't even know the concept, but I'll still try to make it easier for you. It's not that important, but then knowing that will be good if you go for some astronomical observations, because you know. So parsec. Parsec is, this par stands for parallax and sec stands for the angle. Parallax and second. Okay. Now this second is not time ka second. This is not time ka second. This is angle ka second. Okay. Although the relation is same, but I'll tell you how much, how this is different. So seconds. You know, when we say it's, if some people want like, if this is 1 degree in your protractor, you see this is 1 degree, there are some minute, again, subdivisions. So then 1 degree के अंदर होंगे फिर minutes का भी तो subsections, if you do the smaller, very small, they will be second, okay? So what is the relation between that? We know, so 1 degree, 1 radian actually. We convert that angle so where are we? Yeah. So we already know 1 minute is how much? 60 second, right? And the initial 1 degree is 60 minutes. Like I told you, it is already subdivided into minutes, and then 1 minute is subdivided into second. So if I want to convert 1 degree in terms of second, I will do what? 60 minute. So I know what is 1 minute, 60 seconds. So I'll convert 1 minute into 60 seconds. So 1 degree is equal to 60 into 60 is what? 3600 seconds. Why I am doing this? If you see your parsec par, you will see they have used 3600 in the division. And you see 3600, and why do they do that? Because they have something called this 1 degree and 3600 second, and this whole topic, like the whole unit, is about 1 second. Is how much? 1 second. I'll explain why 1 second, but there is sec, right? 1 second. So 1 degree is equal to 3600 second. Then what is 1 second equal to? You know, you have to bring it to the other side. So it becomes 1 upon 3600 degree. Do you see this? And that is why it is 1 upon 3600. Something like that. So let's ignore those numbers. It's just for your knowledge. You should know that it is degrees subdivided to minutes. Minute is subdivided into second. But this second is not your time. This second is what? Angles. Okay. So what is parsec? Like we said, like astronomical unit, like light year, parsec is also measuring distance. Okay. So what is this distance? It says the distance from the semi-major axis. What is semi-major axis? This is sun. This is earth. You know that sun and earth, we do not rotate, revolve in a perfect circular angle, perfect circular shape. Do we have a perfect circular orbit? No, it is what? Parabolic, we call it parabolic or oval shape. Right?
It's not stuck at a place, right?
Sorry?
It is not stuck at a place. It moves forward.
What
It
is it?
revolves, but saying it revolves.
Yeah, that's what I'm saying. But the
No, ma'am. It is not stuck in a place. Like it does not revolve. Like the sun and it does not stay. The sun also moves and the sun also moves around.
in that sense, everything is moving because what is that Big Bang theory saying? Universe is expanding, right? And sun is also in some galaxy. The other galaxies are also influencing the other galaxy stars, other galaxy masses. But we are only talking about Earth and sun now, right? So that motion is this. That is okay because we don't have to go into that because this is very simple definition. Why I'm saying this because again, those definitions are using terms which you are not aware of. So this is sun, this is Earth. You see there is semi-major axis, right? So what is semi-major axis? You see this diameter, one is this. If this was circle, there will be one diameter, another diameter. This is semi-minor axis, and of course, this one would be semi-major axis. Is this clear to you? So they say the angle made, sorry, since this is distance unit, so distance from the semi-major axis, so distance from the semi-major axis, distance of what basically, what is this? This is astronomy के लिए use किया गया distance. So किसकी दूरी मापे रहा भाई हमसे कौन सा स्टार कितना दूर है, right? So let's say there is one star far away from us. If that star is how far is that from semi-major axis? If it is making, like if I watch the star from here or here, there will be one angle subtended, right? There is something called parallax error. If you have heard, if you have not heard, it's fine. What happens when you're here? You think that image is on this path, like here somewhere. Okay, and when you come here, it is here. From mathematical calculation, then they decide, okay, where they intersect, that star is actually there. That is called parallax error. Okay, you must have seen this when you are taking the measurement also, and the ruler is like that. If you do not see straight and you see like this, then you will say, oh, 1.1 is over there. If you see it from this, 1.1 is over here. But then when you check, oh no, that is not exactly 1.1. It is slightly more or slightly less. That is what this thing is. But what's the main thing? Parsec is distance. Distance of this star. What is 1 parsec? Basically, we are talking about what is 1 parsec. Like what is 1 meter? Itna 1 meter. So what is 1 parsec? 1 parsec is this distance of star from the which axis? It's not from Earth or Sun. We do not say from Earth or Sun. We say from semi-major axis. If the angle is 1 second. Okay, 1 arc-sec. Basically, the angle is 1 arc-sec. Is this understood? Then we call that distance as, like, then we call this distance as 1 parsec, EC. Okay, this is done. Oh my god, the class is over. Okay, 6:20 to 7:20, right? I think I am 7:30. Okay, we have overdone it. I hope this is clear. I try to make it.
Can I just repeat? I just want to clarify. How parsec is the distance from the semi-major axis if the angle is 1 second?
If the angle subtended is 1 arc-sec. We say second arc-sec. Okay. You read that again if you do not understand, let me know. Okay. Go through it. You want it off. So you want to increase the temperature? I'll ask you to increase the temperature. Okay. Wow, thank you for the class. Okay, I don't think so. I will be able to copy your information, but I'll definitely pass it to my Okay, thank you so much. I will definitely pass to the ones. Which school are you from? Okay, thank you. Thank you. Let me know if you have any doubts in next class. Okay. And do remember those ones which are important. I may ask you that.